Hello everybody, Bass Action here is back in action. I am sorry that I'm not there with you live and in person today. Thanks for your patience, and I want to just remind you that if there's anything that I go over in the video today that you can't figure out with someone in your group, someone in the classroom, the substitute, if you don't have time to pop in to see me before school, then please just know that we are going to have a whole class period on Wednesday to get all of our questions answered. Nobody else gets a full class period on Wednesday except for you guys. So don't stress too much about it, but I think a lot of this is going to be pretty straightforward for you. Okay, so jumping into examples 1 and 2, they are actually closely related to each other. So we're going to be looking at these two first. And in the first one, it wants us to find the remainder. And in the second one, it asks us to determine if something is a factor. We can use one of two techniques for both of these. We can either choose to do synthetic division, or we can actually just evaluate. We're going to use a different technique on each one because they look a little bit differently and it's a little more convenient on one versus the other. So on our first one, we're going to do our synthetic division because we can see that we don't have nearly as many missing terms on this problem as we would if we had this one. So on our second example with the degree 24, if we try to expand this out, there are a lot of terms missing, a lot of exponents missing, versus this one isn't quite so bad. The other thing on this one, why I would choose to do synthetic division, is because when I do my synthetic, I'm going to need to do my synthetic or evaluate with a negative number, and the negatives just tend to introduce more complexity to our computations. So we're going to go ahead, we're going to set up our synthetic division. I mentioned in the other video that I always like to start with my highest exponent and then count backwards. So 6, 5, 4, 3, 2, 1, 0. Just helps us keep in mind that we have to fill in placeholders there. So I'm going to do this big box. I've seen people do this lots of other ways. You don't have to do the big box. We're going to fill in our exponents or our coefficients underneath each of the exponents. So I'll have a 2, I'll have a negative 18, I'll have a 1, and I'll have a negative 9, which means all of these other spots need to be zeros. It's also really helpful to mark these out. Those coefficients at the top can be helpful later, but for right now we can just mark those out. So we're going to do our synthetic division with our negative 3, because what we're really doing is we're thinking about what value makes this binomial equal 0. Following our synthetic, this first spot is a 0. We add straight down, and then we're going to multiply, and then we're going to add straight down, and then we're going to multiply, add straight down, multiply, add, multiply, multiply, and we get a 0. So if it asks us to find our remainder on this particular problem, our remainder is 0. So the remainder is what is ever right there. It doesn't have to be 0. We remember that when it is 0, it's really nice because that means that f of negative 3 equals 0, or in other words, the point negative 3, 0 is actually on our graph, and of course that would be a nice x-intercept. So that makes that useful, but of course it's not always going to be a 0. Now our next one, as I said, we have a lot of missing exponents here. So we can see all these placeholders that we had to put there. We'd have to put so many placeholders there, it would just be a pain. So what we can do instead is we can just evaluate this function at 1. So we can find what is f of 1. And we can just plug in that 1 and start evaluating. So I'd have my 2 times 1, and our 5 minus my 18 plus my 2 plus my 9. So I'm going to end up with a negative 11, just kind of collecting some of my terms, plus an 11, and I get a 0. So if we're asking ourselves, is x minus 1 a factor of this function, since we get that f of 1 is 0, our answer is yes. If the remainder was anything other than 0, we would say no, it's not a factor, but because it is, we can say that it is a factor. Before I move on to the next one, I want to go back up to example 1, and I want to call your attention to one last thing about this particular dividend. When I look at this dividend right here, this 2x to the 6th minus the 18x to the 4th plus x squared minus 9, I want you to be comfortable recognizing that this particular dividend right here, this polynomial with 4 terms, could factor by grouping. Now, when I say factor by grouping, okay, if that is not ringing a bell in your head, or you're thinking, oh, I was never good with factoring by grouping, please, please, please pop in tomorrow morning or write yourself a note right this second that you want to talk about factoring by grouping on Wednesday in class, because it's a really important skill for the remainder of this chapter. Okay, let's go down to our example 3, and we're going to factor this and solve it. And in this particular lesson, I am not following the textbook. What I am doing is I am going to give you some type of a hint on every single problem that you do. So you'll either be told that something is a factor, something is a 0, or on this one, you will be given a graph. So your hint on this problem is the graph itself. So we can look at the graph and find the 0. And what we can see is that we have a 0 right here at 2. So we have a 0 of 2. Now, this 0 of 2 isn't just a regular 0. We can see that it's a double, okay? So this is what we would think of as a double, or if you're using our language from the pre-calc, you would say that it has a multiplicity of 2, which sounds kind of weird that our 0 of 2 has a multiplicity of 2, but we're going to keep that in mind. So now, when we go to start our synthetic division, we know exactly where to start. So let's go ahead and get that set up. So again, I like to put in these exponents, and then I fill in my coefficients. So I'm going to do my synthetic division with the 2. So let's go ahead and do that. I'll fill it out, and you can go ahead and do yours as well. Okay, so I got 0, which was exactly what I was expecting for my remainder because my graph says it's a factor. Remember, if we get a remainder other than 0, but our graph is saying it should be a 0, then we've probably done something wrong in our algebra. Now, since our graph is showing that this is a double 0, a multiplicity of 2, then that means that I didn't just have a 0 where x equals 2, but I have this again. So you may or may not have seen this in your Algebra 2 courses, but we can actually hook on another synthetic division, kind of like a train car, and we can do our synthetic division again with the reduced polynomial and that second 0 of 2. So go ahead and let's work that one. And we got 0 again, just like we wanted. So we can write this in its factored form. We can have an x minus 2 and an x minus 2. And then I have my reduced polynomial that is now down to a degree 2. And what I know is that this polynomial, this quadratic right here, is not going to factor anymore. If this factored, then I should be able to find its zeros somewhere along the x-axis. But since there aren't any, I know that there's no way that these zeros could be real numbers. They have to be something imaginary. So I can stop right here with my factoring, knowing it's not going to factor. And then if I want to solve this, I can set this equal to 0. So I'm going to rewrite it. Now, we already know that these are going to give us our x equals 2. And then our last one here, our temptation, your temptation often is to jump into the quadratic formula, but I really don't want you to do that. I really want you to recognize that completing the square is the very best technique on this. Why? It is the best technique because my leading coefficient is a positive 1 and my b value is even. Guys, this is going to be 10 times easier to do with completing the square, so stick with me here. So we're going to complete the square, and we're going to say x squared minus 4x. I'm going to put our blank. I'm going to move my 5 to the other side. Okay. Now, if I take my negative 4 and I divide by 2 and square it, I get 4. Balance out my equation. Now the left-hand side becomes x minus 2, quantity squared, equals a negative 1. Now I can take the square root of each side. So I get an x minus 2. I know that the square root of 1, negative 1 is just I. I know I have to have a plus or minus. So my remaining answers are 2 plus and minus I. Way, way easier to do than the quadratic formula. So that's all that I have in terms of this warm-up. When you jump into your notes, you are going to have some hints, so be sure to look at the syllabus. Okay, when you look at the syllabus there, look at it carefully, because the syllabus next to each of the problems is going to give you some type of a hint that the book is not going to provide for you. So those are my hints to kind of build us up and wean us off of needing those. So we're just going to take it step by step. All right, again, if you have any questions, please, please, please come and see me before school tomorrow or jot your questions down and we can answer them in class on Wednesday.